Okay, here we go. We are going to work out some of these problems. I will go through 8 through 19. I'm going to go fairly quickly, but feel free to pause the video or whatnot. The general plan on each and every one of these is to look at the denominators and then figure out what the least common denominator is. So step one, you got to find the least common denominator. And then step two, you're going to multiply every term by that least common denominator. After you do that and you reduce and stuff, you won't have any fractions to deal with at all, but you might have a quadratic. So it could have a squared term, regular, and then a constant. And if that happens, then we are going to solve that by getting it equal to 0. But how we solve it depends on what we end up with. So like if we look at number 8 and number 9, when we do these, they are not going to end up being quadratics, and actually neither will number 10 or 11. But then we might start getting into some messiness. When you start having variables and you're multiplying everything through by a variable, you're going to run into possibly a quadratic situation. So I've written out number 8 here. My two denominators are a 4 and an 8. So the least common denominator would be an 8. So if I go and I multiply each term by 8, and I have to multiply everything by an 8. And if I do that, I can reduce, and I should get rid of all my denominators. So if I do 8 divided by 4, that's going to reduce to a 2. And then I take 2 times 1, this is 2. Minus, nothing cancels here, so I get 8x equals, and then here the 8's are going to cancel out altogether, so it'll equal an x. And now I have a much simpler equation. I just need to get my x's on one side, everything else on the other. Fastest route to that is going to be to add 8 x's to each side, and that'll get all your x's on the right side. So if that goes away, then I get 2 equals 9x. Divide by 9, and we are done. I get x equals 2/9, and not a pleasant answer, but I assume it will work. You could check it back into the original if you wanted to. So I'm just going to crank through them, doing that same sort of thing each and every time. I'm going to clear this, so if you want to see each problem again, you're going to have to just go back in the video. It shouldn't be a big deal, I wouldn't think. You could pause it and write it down. There you go. So let's move on to number 9. Number 9, we have y divided by 5 plus y divided by 2 equals 7. My two denominators are 10, or 5 and 2, so my least common denominator is 10. So I'm going to go through it. I'm going to multiply every term by a 10. And I didn't put my little time signs there, but 10 divided by 5 here, it's going to be a 2. So this is going to be 2y. And then 10 divided by 2 is a 5, so that's going to be 5y. And then equals 7 times 10, nothing reduces there, so that's 70. And this one ends up having a much nicer answer, because I could combine those two to get 7y is 70 divided by 7, and we get y to be 10. And let's see, we should be able to check that. 10 divided by 5 is 2, and 10 divided by 2 is 5, and 2 and 5 add up to the 7. So it actually worked out quite nicely on that one. Let's move on to number 10. Number 10, we have 2x over 3 minus 1 over 2 is equal to 2x plus 5 over 6. 3, 2, and a 6, my least common denominator is 6. So I'm going to multiply everything by a 6. And when I multiply by a 6 here, this 6 and this 3 are going to reduce to a 2. And then I have to take that 2 times 2x. So that's going to give me 4x. This 6 and that 2 are going to reduce to a 3. And that 3 gets multiplied by that 1, so it's minus 3. And here the 6's are just going to cancel out. If this didn't totally cancel out, I would need to distribute whatever was left to this 2x and a 5. But since it went ahead and canceled, I'm just going to write 2x plus 5. And now my goal is to get x's on one side, constants on the other. So I'm going to take away 2 x's from each side. and that's going to get my x's on the left. So I get 2x minus 3 is equal to 5. I'm now going to add 3 to get my constants on the right. And so I end up with 2x equals 8. And when I divide by 2, I get x equals 4. Nice answer. See if we can check this. 8 over 3 minus 1 over 2. Yeesh. I'm sure it works, but I don't want to check it. So let's move on to number 11. Number 11, we have 3x minus 2 over a 12 minus a 1 over a 6 equals a 1 over a 6. And so I'm going to do the same process. 12, 6, and 6, my least common denominator is 12. So I'm going to multiply everything through by a 12. And so if I multiply all these by a 12, here the 12s are going to cancel. So I'm going to get 3x minus 2. Here the 12 and the 6 is going to reduce to a 2, and that 2 gets multiplied by that 1, so minus 2. And then we get equals, and 12 divided by 6 is again 2 times that 1 equals 2. So I can combine these two together. Take minus 2 from here, and then this minus 2 is going to be minus 4. So I get 3x minus 4 equals 2. I want my constants on the opposite side of the variable, so I'm going to add 4 to do that. And I get 3x equals 6 divided by 3 to get rid of the coefficient, and I get x equals 2. And we should be able to check this one. 2, it's going to give me, what do we got here? 6 minus 2 is 4. The third minus a 6 equals a 6. Yes, that actually does work out. So let's move on to number 12. And this one starts to get a little funky because we have variables in the denominator. But the variables are just part of your least common denominator, so that shouldn't really change the process any. So number 12. Let me get it down. 1 over x plus x over 2 is equal to an x plus 4 over a 2x. So if you look at your denominators, we have a 2 and a 2, so I need a 2, but I also need an x. I have a denominator that has an x in it, so my least common denominator is going to be a 2x. So I'm going to multiply every piece by a 2x. And if I multiply all the pieces by a 2x, here the x is going to cancel out. So I'm going to get a 2, because 2 times 1. Plus, here the 2 is going to cancel out, and I have x times x, and that's x to the second. And then we have equals. Here the 2x and the 2x are going to totally cancel out, so I'll get x plus 4. And we have a quadratic. When you have an x squared term, you want to get it equal to 0, so you can either factor it or use the quadratic formula. I don't know if you all have covered the quadratic formula or not. But I want the x squared, the x, and the constant all on one side equal 0. So I'm going to take away an x and take away the 4. I'm going to get rid of both of these things. So I'm going to take away an x and take away a 4. Now I put the minus x not underneath either one of those because it's not a like term to a constant or an x squared. But I put the minus 4 under the 2 because they're both constants. So this is going to cancel, this is going to cancel, I'm going to get 0. And now I want to put it in descending powers. I want this x squared first because it has the highest exponent. And then I have the minus x, and then I have the result of 2 minus 4, which would be minus 2. And I happen to notice that this should factor nicely. I don't know how I know that. Really, 2 times 1 is 1 apart, and so there we go. So I'm going to factor this, and if you factor it, you know that something times something equals 0, so you can figure out what it's going to take to make each one of these 0. So the first terms have to multiply to x squared. So this first term here and this first term here have to both be x's. And then the number here and the number here have to multiply to negative 2. So there's got to be a 1 and a 2. this one could be positive and this one negative, or this one negative and this one positive. But the result of the, and I don't know if they teach the FOIL method anymore, but 2x and 1x, I want the result of that to be a negative 1x. So I need to put the negative on the 2 and a positive on the 1. And then I can check the x times x is the x squared. I'm going to get a negative 2x and a 1x, which will combine to this negative 1x, and then a positive 1 and a negative 2 multiplied to negative 2. Now that this is factored, I can just figure out what would make that 0. Well, x equals negative 1 would make that 0. So that's one answer. And, and then what would make this one 0 would be x equals 2. So I have two answers. The only thing I need to check is if x is one of these two numbers, would it make a denominator 0? If you get an answer that makes a denominator 0, it is not a real answer. Those are called extraneous roots. I don't know if you talked about those or not, but neither one of these, if I put a negative 1 here and here, that's not going to make a 0 in the denominator. And if I put a 2 in either of those, it's not going to make a 0 in the denominator. So both of those would be answers on number 12. Let's go to number 13. So I'll clear out that one and go to 13. So on 13, we have 11 over 3x minus 1 over 3 is equal to negative 4 over an x squared. So my least common denominator is got to have a 3 in it, but it also has to have an x squared. So it's going to be 3x squared. So I'm going to multiply everything by a 3x squared. And so when I multiply by a 3x squared, there's some messiness, but a lot of it cancels out. So this 3 and that 3 are going to cancel. And then this is x times x, and so this x is going to cancel out one of these, so I'm just going to scribble out the 2. And so we get an x times 11, that'll be 11x. Here the 3 is going to cancel, and I get a minus x squared. Here the x squareds are going to cancel, and so negative 4 times 3 is negative 12. And so we again have a quadratic. I like having the coefficient of my x squared term be positive. So rather than to add 12 to get it over here, I'm going to take away these two, take away this and this to get it all over here. So I'm going to take away 11x and add an x squared, and take away 11x and add an x squared. And so I get 0, because these will go away. And then I get x squared minus 11x minus 12. So I put the highest degree term first, and then the minus 11x, and then the minus 12. And so I'm again going to try to factor this thing, and I think it'll factor because 12 times 1 is 12, and 12 and 1 are 11 apart. So I think I can factor this into an x, and it's going to be a minus 12 and a plus 1. And I can check this is plus 1x, and this is minus 12x. That'll be that one. Negative 12 and positive 1 multiply there. And x times x is x squared. So what will make that one 0? Well, x equals 12 would. So that's an answer. And then what would make this one 0? Well, x equals negative 1 would make that one 0. But then I make sure I go up here. Would either of these make a denominator 0? And they wouldn't, so they are both answers on that particular equation. Let's go on to 14. Number 14, we have 3 over 2x minus 5 over 3x, and that equals 2. My common denominator needs to have a 2, a 3, and an x. So it's going to be 2 times 3 would be 6, so it's going to be 6x. So I'm going to multiply everything by a 6x. So the x's are going to cancel here. The 6 and the 2 reduce to a 3. And that 3 gets multiplied by that 3, giving me a 9. Minus, here the x is going to cancel. 6 divided by 3 reduces to a 2. And that 2 gets multiplied by that 5. So it's minus 10. equals, nothing cancels here, so it's just 2 times 6x, it's 12x. And this is kind of nice here, even though it's a negative, I can combine these two because they're both just constants. So that's negative 1 is equal to 12x. And then we'll divide by the 12 and we get a fraction. It's a negative, but it's fine. So negative 1/12. And that would not make a denominator 0, so we are good to go. Let's move on to 15. Number 15, we have 5x over 4 minus 3 over x equals a 1 over 4. My least common denominator has to have a 4 and an x, so it's going to be 4x. So I'm going to multiply every term by a 4x. So here the 4's cancel, and I have x times 5x. Well, that's x times x is x squared, so this is going to give me 5x squared. It might not be very pleasant here. Here the x is going to cancel, and 4 times 3 is 12, so it's minus 12. And then here the 4 is going to cancel, and 1 times x is just x, so it equals x. So anytime you have a quadratic, make it equal to 0. So I'm going to take away that x, and that'll get me all my terms on the left. So it's going to be 5x squared minus x minus 12 equals 0. And I have to try to factor this thing. If it has a 5 here, what that means is if this thing factors, it's going to have a 5x and an x. And 5x times x will give me the 5x squared. And now I need to figure out two numbers that multiply to 12. And I'm going to put one of them here and one of them here. I don't know how you all are taught the factoring method now, but I'm going to try to get a number here and a number here, knowing that this one is going to get multiplied by the 5x, and this one's going to get multiplied by the x, and I want the result of that to be a negative 1x. So like if I put, let's just say I put a 12 here and a 1 here, that's going to give me a 5x and a 12x, and that's not going to be right. So I am not going to put the 12 and the 1 there for permanent. I just wanted to show you kind of the idea of we're after here. So I am going to try another route here. So what if I put let's go with let's see, if this is a 1, it'd be a 5 and a 12. If this was a 2, this would be a 10 and a 6. If this was a 3, be a 15 and a 4. I'm not seeing that this is going to factor nicely at all. Maybe I'm missing something, but I'm not seeing that. If in doubt, use the quadratic formula, I guess. So I don't know if you know the quadratic formula or not, but it's this is my A, and this is my B, and this is my C. So it's going to be 1 plus or minus the square root of a negative 1 squared minus 4 times A times C all over 2 times A. And that is not very pleasant. What is that? 1, that's going to be 2241. 21, 1 plus 20, 22. I don't know that this is going to be very pleasant. I'll pull out my trusty calculator here with it on, of course. And so oh, 1 plus 4 times 5 times 12, and the square root of that. That is horrible. Maybe I messed up. I don't know. I don't know if you all have done those before. Did I write it down correctly? 5x over 4 plus minus 3 over x equals 1 over 4. X minus... This is unpleasant. I'm getting 1 plus or minus the square root of 241 over 10. And that doesn't seem like that should be right, but that appears as though what I am getting. Let me double check here. Make sure I multiplied everything by a 4x, and the 4's cancel, leaving the x 5x squared. Then we got the x canceling, leaving the 12. The 4 cancel, leaving the x. Yeah, it looks like I've done that. Is unpleasant. I might revisit that one. If I revisit, I'll send you my thoughts on that. I don't know if I messed up or that just has a horrible answer. Guess we'll find out. So let's move on to 16. 16, 2 over y minus, plus 1 over 2 is equal to 5 over 2y. And then 2 times y is going to be my denominator. So 2 times y and 2 times y and 2 times y. I multiply everything by that. So the y cancels on that one, leaving 2 times 2, which is 4. Plus the 2 is going to cancel. Y times 1 is y. Equals the 2y is going to cancel, and you end up with a 5. And I like this one a lot better. I'll take away 4 and get y to be 1. That is quite a bit easier than the previous one that we had. So let's move on to 17. Heck, I'll put it on the same one here. Maybe it'll fit. 17, x plus 6 over x equals negative 5. The only denominator I have is an x, so I'm going to go through and multiply everything by an x times an x. And let's erase that. Times an x and then times an x. So when I multiply an x times an x, I get an x squared. Plus, here the x is going to cancel, leaving a 6. Equals, here I get negative 5x. And so I'm going to add 5x, and I get x squared plus 5x plus 6 is equal to 0. And I get x plus 2 and x plus 3. I like how that one factored a lot better, because 2 times 3 will give me the 6, and then a 3x and a 2x give me that 5x. So what would make that one 0? Negative 2. And what would make this one 0? Negative 3. Man, it almost makes me think I messed up that number 15, since everything else is working out so nicely. So maybe at the end of this block I'll go back and redo 15 to see if I get the same thing again. So let's do 18 and 19. So 18, we have 1 over 4x minus 3 over 4 is equal to 7 over x. My least common denominator is a 4x, so I'm going to multiply by 4x, and by 4x. And so the 4x's cancel, leaving a 1, minus the 4's cancel, leaving a 3x, so minus 3x, equals, and here the x cancels, and we end up with 4 times 7 is 28. I'm going to take away 1, and get negative 3x equals 27. Divide by negative 3, and I get x equals negative 9. That one seemed to work out quite nicely. That does not make a denominator 0, so we're good to go there. 19 looks like it might be a little involved, so I'm going to go to a blank page here. 19, we have 5 over 2x minus 2 over 3 is equal to 1 over x plus 5 sixths. My least common denominator has to have an x in it, and then it has to have a 2 and a 3, but that'll a 6. So I'm going to multiply everything by a 6 and an x. So 6x, 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 6x. Every piece gets multiplied by that least common denominator. So the x's will cancel. 6 divided by 2 is 3, so that's 3 times 5, that's going to be 15. Here the 6 and the 3 reduce to a 2. 2 times 2 is 4 with that x, so minus 4x. Equals, here the x is going to cancel. 6 times 1 is 6. And here the 6 is going to cancel, leaving 5x. So I want x's on one side, everything else on the other. I'm going to add 4 x's to get all my x's on the right. And so I get 15 is equal to 6 plus 9x. I'm going to take away the 6, take away the 6. Wow, I'm going to erase that. That looks terrible. No, seriously, I'm going to erase it. I'm going to take away 6 from each side to get the constant on the opposite side of the variable. So I get 9 equals 9x, and so when I divide by 9, I get x equals 1. So that's really making me think about number 15, so just for the fun of it, I'm going to work 15 here again and see what happens. So I'm going to redo 15 to see if it ends up being messy again. So 15, make sure I write it down right. That's a key thing. 5x over 4 minus 3 over x is equal to 1 over 4. And so let's see, I'm going to go to a different color so I can track my work a little bit. So I'm going to multiply everything by a 4 and an x. So 4x, 4x, and 4x. So the 4 is going to cancel here. X times 5x is 5x squared. The x is going to cancel, leaving minus 12. And then the 4 is going to cancel, leaving an x. And then I'll take away an x from both sides. And I get 5x squared minus x minus 12 equals 0. And that seems like it's the same thing we had before. 1 minus 4 times 5 times. Yeah, that's the same horrible stuff again. So the quadratic formula would be negative b plus or minus the square root of b squared minus 4ac all over 2a. And so this number right here is your a, this negative 1 is your b, and this negative 12 is your c. And you throw them in there and it doesn't work out very pleasant. But I don't know about 15. All the others worked out nicely. So there's the first half of it, and we'll stop the video here and then I'll do the other half.